My name is Mark Powell. I'm the Scientific Manager of Key Pharmaceuticals, and the subject of the presentation is the analysis of an adulterated herbal medicinal product. Key Pharmaceuticals is a UK-based contract research organisation that specialises in drug development. And a couple of years back we were asked by one of our clients to help them to develop a herbal medicinal product for manufacture in the UK. And this was a product that they'd been importing from a supplier in Malaysia. The reason that they asked us to do this was a change in the legislation. In 2011, the European Herbal Medicines Directive was introduced to the UK, which requires all herbal medicines to be registered. And to do that, of course, you need to characterise them. So the herbal medicinal product that we're talking about was marketed for the relief of arthritic pain, and it was supposed to contain 13 individual herbs as a simple powdered blend filled into hard gelatin capsules. So our approach was to develop a gradient HPLC method, which we did, and that provided good resolution between the principal peaks in the herbal product chromatogram. And the next step then was to run extracts of the individual herbs, which we sourced from a reliable supplier in the UK. And then what we wanted to do was to map the principal peaks in the individual herbal chromatograms to the peaks in the herbal medicinal product, so that we could work out how much of each individual herb was present in the drug product. We also ran marker compounds that are listed in the Chinese Pharmacopoeia that we wanted to use to confirm the absence of the different herbs. So here's the herbal product chromatogram that we obtained using that gradient method. And you can see a number of prominent peaks. If you were to zoom in on the baseline, you'd see that there are quite a large number of minor peaks in this chromatogram as well. But for now we focused on the major peaks. We were faced then with two problems. The first problem was that when we ran the individual herbal extracts and tried to identify the peaks in the drug product chromatogram that belonged to the individual herbs, we couldn't actually match those up. And the second problem was our client contacted us to say that the UK regulator claims to have found the prescription-only antihistamine chlorpheniramine in the herbal drug product. So our first job was to check out that claim of the presence of chlorpheniramine. When our client followed this up with the supplier in Malaysia, they were told not to worry, that the regulator had probably mistaken chlorhydrine for chlorpheniramine in the drug product. Now, chlorhydrine is a phytochemical that's present in some herbal medicines. So we checked this out by running a combined standard of chlorpheniramine and chlorhydrine, which you can see in the bottom chromatogram of this slide. And the top chromatogram shows the drug product, and you can see that there's a peak in the drug product that lines up very nicely with the chlorpheniramine peak, but there's nothing really that ties in as nicely with the chlorhydrine peak. So for final confirmation, if we compare the UV spectra of these two peaks in the drug product sample with reference UV spectra, we can see that the UV spectrum in the drug product chromatogram doesn't match chlorhydrine, but it's a very good match for chlorpheniramine. So the conclusion there was that chlorpheniramine is present in these herbal capsules and chlorhydrine is not. So we quantified the amount of chlorpheniramine, and as free base there's roughly 1.5 milligrams in each capsule, and that's equivalent to 2 milligrams of chlorpheniramine maleate, which is the species that's normally prescribed. Now, this herbal medicinal product, the recommended dose for it is 2 capsules a day. So if you take 2 capsules of this herbal medicinal product, what you're taking is 4 milligrams of chlorpheniramine maleate, which is equivalent to the normal adult dose. But the normal pediatric dose is much less than that, it's 1 milligram. So any children taking this herbal medicine are actually taking more than the recommended daily amount of chlorpheniramine. So as we've already said, the capsules do not contain chlorhydrine, and the other conclusion, of course, is that we now don't trust the manufacturer because they are lying to us. So at this stage we had some unanswered questions. Firstly, what are the principal peaks in the UV chromatogram? We know that they don't belong to the herbs. Do the capsules contain any herbal material at all, and if so, which herbs are present? And the different batches of capsules contain the same ingredients. Are they the same? Are they made consistently? Or are they very variable? Now, to answer these questions, we needed analysis by LC-MS with data reduction software. So Key approached Waters for help in the analysis of these herbal medicines. And we sent Key samples of 7 batches of herbal product, 24 individual herbs, that's the 12 individual herbs that are supposed to be present in the medicine, plus a further 12 that we thought might be present, and 5 suspected adulterants. In the meantime, after the analysis of the product for chlorpheniramine, we received some information from our client that suggested that there might be other adulterants present, so we sent those off as well. We also sent Waters 11 individual reference compounds, 9 of which are mentioned in the Chinese Pharmacopoeia, and a further 2 are mentioned in literature sources. So this is the first piece of data that we got back from Waters, and it's a mass chromatogram confirming the presence of caffeine, chlorpheniramine, piroxicam, beta-methazone and oxethazane in the drug products. And it's clear from this chromatogram that the most prominent peaks are the adulterants. So let's just compare the amount of adulterant that we found in the capsules with their therapeutic amounts. So beta-methazone is an anti-inflammatory, and if you take 2 herbal product capsules, you're taking 10 milligrams of beta-methazone. The recommended dose in adults, and these data are taken from the British National Formulary, is between 0.5 milligram and 5 milligrams. Caffeine is present at below the recommended dose, so that's of less concern. Chlorpheniramine maleate we've already discussed, and there are concerns there about the amount of chlorpheniramine that's present compared to the pediatric dose. For oxethazane, again, we've got an amount of oxethazane in 2 capsules that is roughly equivalent to its therapeutic dose in adults. And for piroxicam, we've got 10 milligrams of piroxicam present, which is a little bit less than the adult recommended dose, but exceeds the recommended dose in children. So the question really is, where is the therapeutic effect coming from? Is it coming from any herbs that are present in the product, or is it coming from the Western medicines? Because it's clear that these Western drugs are present in the capsules generally at or above their therapeutic limits. So there's the list of the herbs that were supposed to be in the capsules. As I've already mentioned, we ran 11 marker compounds that are characteristic of these herbs. For these different herbs, there are 16 marker compounds listed in the Chinese Pharmacopoeia. We only managed to source 9 of those, and as I've mentioned, the other 2 marker compounds we took from a literature source. So here's a graph showing how these various marker compounds map to the different batches of herbal product. We found 3 marker compounds in the herbal capsules, and these suggested the presence of 3 herbal substances: mugua, dangui and huangqi. So the next question is, are the capsule contents consistent? And for this we used multivariate analysis, principal component analysis, by grouping the data from the different herbal capsule batches. And you can see now from if we overlay the chromatograms of the different batches, you can see why we need data reduction, because it's very difficult to see from a visual standpoint any differences between these herbal products. Perhaps you can see there's a suggestion that some of the peaks are present in some chromatograms and not in others, and there are some peaks that are present in different ratios in one chromatogram compared to the other. But if you're to conclude overall what the differences are and what their significance is, that will be quite difficult to do on the basis of a visual analysis. So here's a score plot of the different herbal product batches, and you can see that there are 3 principal groups. So batches A, B and C group in the right hand side of the graph. Batch G groups in the top left-hand quadrant, and batches E and F group in the bottom left-hand quadrant. So if we now move to a loading plot, we can see which particular marker peaks are causing those differences. So you can see that the differences in batch G are caused by this marker up here in the top left-hand quadrant, and this group of markers in the bottom left-hand quadrant is responsible for the differences in batches E and F. So let's take a look now at peak area data for the various marker compounds that we've used. So in this slide you can see a list of the retention times for the different marker compounds, their mass, their elemental composition based on accurate mass data, and hits in databases for likely compounds. So if you look at the top half of this slide, you can see that the peak area data in red here, these are peak area data for these marker compounds in batches E and F. So the marker compounds here are more prominent in batches E and F than they are in batch G, and in the bottom half of the slide you can see a group of marker compounds that are more prominent in batch G than they are in batches E and F. The thing to note though is that if we look at the factor of change, where we see a large factor of change, the corresponding peak area data tend to be small, and where we see large peak areas, in other words these compounds that are present at relatively large amounts, the factor of change is actually very small. So if you consider the difference in composition of the batches overall, there's not a lot of evidence for a wide difference in composition between the batches of herbal product. Now if we take a look at the entire data set that we obtained, so this is the data for the different capsule batches which are grouped at the top of this slide, and for the 24 individual herbal substances that we tested. What's very evident here is that the various peaks that we found, the various marker peaks that we found in the capsule samples are all present in a sample of gan cow. Gan cow is licorice root. So it looks on the base of this slide as if the presence of gan cow in the capsule samples can account for the presence of all those marker peaks that we see in the mass chromatograms. So let's go back to the slide that we saw earlier, where we're looking at the amount of the marker compounds present in the individual herbal capsule batches, and now let's superimpose on that slide the data from gan cow. And you can see that the contribution from gan cow dwarfs everything else. So it's a reasonable conclusion that the only herbal medicine that's present in any appreciable amounts in this sample is licorice root, which of course is not on the list of ingredients that's supposed to be present. So let's go back to our initial questions. We now know that the principal peaks in the herbal product chromatograms are adulterants. They're conventional Western medicines that have been used to adulterate the herbal product capsules. Are there any herbs present? Yes, we know that gan cow is present, and that looks to be the only herbal medicine that's present at appreciable amounts. And the other question that we asked was, are the capsule batches manufactured consistently? And I think we've seen from the data in the principal component analysis that there is a reasonably good consistency between the capsule batches, although there are some minor variations. So, what are the take-home messages? The first message is that the regulation of herbal medicines is vital. It's quite clear that the manufacture of this herbal medicinal product is not to be trusted. So you should never take anything on trust. Make sure that you check suppliers by auditing them and test their products independently. And the other important component of this work is, of course, the informatics. It would be very, very difficult to do what we did in terms of comparing the composition of the different batches of herbal capsules without data reduction software. Finally, I'd like to acknowledge the help of two colleagues from Key Pharmaceuticals, Alexander Pinnock and Adam Nagel, and of course the help of Waters in the analysis of the herbal product samples. Thank you.